that, thank you for providing your time and just coming down here and joining us for some discussions about environmental topics that may be important to your construction project execution. So thank you. Okay, our agenda for today, we're providing welcome introductions. We're also going to go through our camp laws org charts, but I'm also going to invite Ms. Lady Terrell, who's the compliance supervisor for Anderson Air Force Base, to introduce herself and talk about her shop so that you can identify your primary POCs here at Anderson Air Force Base. We also have an ops note update for OICC. We may not cover that if OICC doesn't show up. We also have a stormwater bulletin that we'd like to discuss. That might be of particular interest to the folks here today. Underground injection control wells, oil water separators, and landowner signatories for permits for Guam EPA. And then finally, we'll have Captain Bearden providing some training slides on stormwater. And then we'll close it out with Q&A between everybody, but I encourage this to be a discussion versus just somebody talking up front. So thank you. Next slide. So this is the CAMLOS organization. We have natural resources mitigation branch led by Ms. Lauren Gutierrez. So if you're working, I don't think anybody is working on debris projects here, but we have, I would say special debris mitigations pertaining to the Marine Corps relocation. So you have folks that oversee those requirements. We also have Ms. Cherry Hoya, who's our lead for compliance and planning. She oversees our compliance folks as well as our cultural resource folks for Marine Corps Base Camp Blaz. I work for Commander Guam, who's our public works officer, who works for Colonel Gobea. We have some ties to Joint Region, OICC, GPMO from our debris. Next slide, please. This slide we'll probably skip. This is the Guam Program Management Office. Our point of contact there is Mr. Richard Gray. Actually, if you have some housing projects at Anderson, some of them are debris funded. We work primarily with this outfit led by Ms. Florence Chick. She's the GPMO director. We'll be working pretty soon with our Guam Defense System counterparts in the Joint Posture Management Office. But very similar outfit. We'll be working with these folks on future NOCOMs. Next slide. Omar, you're up.
All right, so my name is Omar Damian. I'm an environmental engineer supporting the Marine Corps Camp Blaz with Alice Group and under compliance. So we put together this debris stormwater bulletin to basically pass out to our OICC counterparts. It's still being finalized, but I'll just go ahead and go through it today, and it applies, across the board to any pretty much construction project as well. So basically, any project that you guys have going on in your construction, you have compliance requirements that need to be met. If you don't meet those requirements, you can violate, the Guam erosion sediment control regulations, the federal EPA construction permit, and specific permits like the clearing and grading permit, which I'm not exactly sure if that applies to non-debris projects.
Let's have a quick discussion on it. So, who amongst the Anderson Air Force Base folks are familiar with the local stormwater map, the Guam EPA stormwater? Anybody? Okay. So, from our perspective, under the waiver of sovereign immunity, I don't know if you've heard of that term. The federal government has subjected itself to local stormwater standards. So what that means is that for any construction project on Guam, these have to be in our design specifications. So if your project is being reviewed for compliance with local requirements, look for design references to the 2006 CNMI Guam stormwater.
Thank you. So basically, EV, right? EV is kind of like the last thing on everybody's mind. Safety first, obviously, right? And then construction is you want to meet all your deadlines. But when you do get a notice of violation, obviously there are issues. You can get a notice of violation from Guam EPA, from US EPA, and then a stop work order, which obviously impacts your project schedule and is just bad in general, right? So the purpose of this bulletin, again, is just to raise more awareness for stormwater compliance and to hopefully, avoid any type of notice of violation or any type of negative impact to the project. Next slide. The stormwater, the CNMI, 2006 CNMI Guam Stormwater Management Manual. I'm not going to go through all of this. Captain Bearden from Guam EPA, the chief engineer, will have a very, very specific, not only what's called stormwater related presentation, but also design what's called a presentation also that will go in depth into this. So just keep that in mind. But in general, you want to always have EMPs on your project and make sure that you're following your SWIP. Next slide. The EPA 2022 construction general permit. That's a federal requirement for any what's called project that you exceed an acre in clearing. You would have to apply for an NOI. Normally, the contractor would do that. I've been involved at NBG in the past where it was required as a dual NOI, so on the FIAD would apply for one and then the contractor would apply for one. That's actually a good question. Do we do that now?
No.
No.
So we just ask our contractors for the FAR permits and responsibilities clause to apply for the NOI themselves. We'll sign off as representative of the manager.
Gotcha. Okay. So basically, yes.
What's the timeline for the NOI after submittal? How long does it usually take?
So, correct me if I'm wrong. How long does what's the timeline for that submittal, and how long does it usually take? I know that it's, in my experience, I know that, and you can chime in, that it's an electronic notification. You do it online, and it's basically you submit the NOI, and you don't necessarily get a quote-unquote approval. You just get what's called a record of your submittal. As on record that you're following and complying with. You're basically like self-certifying that you're complying with the federal permit. Is that correct?
Yeah, so that's correct. So there's a 14-day timeline for US EPA to object to your NOI. And past that date, if there's no objections from US EPA, you can proceed. But that's assuming you already have a completed SWIP that you will be uploading into that ENOI CGP system. The contractor will be doing that. But if all of your information is complete, you submit it to US EPA. EPA has 14 days to object. Past that 14-day time period, they can either hold or basically you're approved. So, if you do get a hold, make sure to contact your environmental office to figure out why your contractor got hold.
Does that answer your question?
Yes.
Any other questions on that? Thank you. Yeah, so for Marine Corps projects, for different projects, regardless of the size of the clearing, we require that the contractor submit the NOI. Again, just kind of talk through that, limiting disturbances, CGP NOI requirements. We want to limit the disturbance, what's called the cumulative earth disturbance to less than 5 acres. At one time, again, there's a kind of asterisk without temporary stabilization and proper BMPs. So you can exceed that as long as you are managing your site appropriately and have appropriate BMPs in place to manage specific portions of your site. The CGP also requires that NOI inspector training. That has to be done and completed. There's a link here for that training. And there's also a link at the very bottom that gives you what's called more information for more requirements. We'll provide what do you call that thing? That hyperlink? The QR code. You can take a picture of the QR code at the end of the presentation, and then you guys can have access to all the slides. And also, we're having it videoed also, so in case somebody wasn't here, they can take a look.
So that's online?
Yeah, that's all online. It'll all be online. Next slide. Local requirements, again, Al kind of spoke about this, the Guam EPA 30 grading permits. Again, if you have any, any more questions about that, there are links. And then also for the certification, there's also a contact at GCC Trades Academy to get that training. Design requirements for sediment traps. This is something that we've been having issues with. I'm not going to say that since but what is it called? Again, make sure that you guys are containing and treating your stormwater and making sure that it's being held on site. So ensuring that you guys have basins that are appropriately sized and properly maintained, that helps with that. Again, Captain Gary will have a bunch of input on that. Next slide.
Real quickly on this slide, Omar. It's 5,500 cubic feet per acre served. So that's an important.
And yep, any questions on stormwater? Again, Captain Gary will have a lot more to offer in terms of details, and there's a lot of information also. So we have via those links. So, next.
All right, good afternoon once again. Next slide, please. So Class B underground injection well is not covered under 2015 SEIS for DOD construction projects. So if you have this UIC well, it has a significant long-term environmental permitting, operating, sampling, and regulatory reporting costs. So marching order for MCBCB will not approve or accept any of these construction designs to include Class B UIC wells. So we have some cases wherein this became an issue. It's on the bottom. Next slide, please. All right, we have a few examples like this one. So anytime you have a UIC that is covered with concrete, then it's considered as a UIC for Guam EPA. Next slide, please. This is another example.
Jerry, can we go back one slide?
All right.
I just want to make sure that it's clear to our folks why this is considered a UIC. Okay. So the general definition of UIC is if you have a well that is the vertical dimension is deeper than the horizontal dimension. So for example, if this was two feet deep and 2 feet wide, then it wouldn't be an underground injection control, right? So we have a lot of condensate pits in our construction projects that Guam EPA has been looking at, saying, why is this an injection well? And because they're actually they're not as deep as they are wide. So that's just one criteria, right? Okay, so
yes.
We're moving on to the next criteria of why Guam EPA considers these underground injection wells, right?
Yes.
All right. Okay.
Right.
Go ahead.
So another one is this condensate infiltration. It is wider than its deep, which is mentioned. So Guam EPA considered this design to be UIC due to the concrete cover.
So if it has a concrete cover, Guam EPA calls it an underground injection control.
Yes.
Okay. So what is the solution?
Also, there are some recommendations. So it should be designed and constructed with horizontal dimension width, which is greater than the vertical dimension, which is the height. So another one, so anytime you have a chamber that may qualify, must not have a solid cover and must provide visibility to the base of infiltration feature.
So you have to be able to see the inside of the well with a drill or a rig.
Also, the design must not contain any drilled engineer orifices into bedrock. So for other additional information, there's a link below. Next slide, please.
Real quickly, maybe have you run, or I'm sorry, sir, go ahead.
We've run into this on several projects. We agree with the differences that make a UIC well versus this regular compensation pit. Are there any discussions on changing what the design should be, either to conform to the EPA requirements and then that we get better designs, or trying to
we've done is we've crafted a bulletin for the designers at NAVFAC PAC to implement what we just discussed, so that there is no issue post-award arguing with Guam EPA about what this condensate pit, whether it falls within the UIC program or not. Because what happens is we have monitoring compliance burdens associated with these UICs. We don't want that. It's basically an unfunded mandate every time we accept this as UICs. So lately, I think you've been trying to pursue the same strategies, right? So the environmental team is trying to push for eliminating underground injection control wells from all of our construction projects, because we actually have sufficient space to not have UICs. Maybe base law may be different, but they can speak for themselves as far as the site-specific issues. Felix, guy.
What are you trying to prevent from going into the ground over
We are not trying to prevent anything. So we're trying to avoid the permits associated with discharging, whatever it is, condensate, processed water, storm water.
process water going into the ground? Is there anything wrong with that?
No, there's nothing wrong with it. We just don't want the compliance costs associated with those permits, because we have sampling, we have monitoring. We don't want to pay for them.
I think that's not really just asking questions. EPA looking at this saying it isn't maybe too stringent.
We made the argument, and they basically pushed back on it. And it's such an easy change from a design standpoint. Let's just roll with it.
Okay.
All right. Yeah. Next speaker, Richard.
So oil water separators. Oil water separators are pre-treatment to wastewater. You'll typically find them in vehicle wash racks, use traps, those types of facilities or those types of fixtures. And Guam EPA governs the oil water separator. You can find those regulations in 10 GCN, Chapter 76, Article 1. OWS require a permit for Guam. Design bid builds, those designs typically get sent to Guam EPA for review. Oil water separators should be indicated in most of those facilities that require such a system. Contractors need to apply for installation in OWS. And it doesn't limit the government's operation. Guam EPA just requires the installation of that. And you can find it in 10 GC 76. It's typically like $580 per order. Next one.
Are we encouraging oil water separators?
Actually, it comes down to UFC compliance. So there's a UFC for wastewater treatment, and in the UFC, depending on the nature or characteristic of your wastewater prior to discharge to sewers or stormwater, there's pre-treatment. Typically, the indicated pre-treatment device is a oil water separator.
And depending on the activity, your Guam EPA will be request one.
Yeah, that's a big public works department issue with oil and water separators, particularly if the boss is not doing their PMIs. It can basically, like you said, it can be a non-functional disaster. So we see that happening. Obviously, we've got to do a better job at that. But as far as for construction goes, they just need their contractors to submit these programs.
Any other questions? Okay, I'm German, talking about landowner signature for the permits. Just wanted the opportunity to improve the accuracy of these permit applications. Next slide, please. First, and really the only point, is to check if your permit application requires the landowner's signature. You can do this by reviewing the applicable regulations, reading the fine print on the application itself, doing a thorough exam. Not all permits require landowner permission. Some examples of permits that do require it are solid waste permits, USTs, or just talking about oil water separators. I believe the permit for that is a UST permit. Test boring permits. I wanted to focus on an example of well drilling permits. So the applicable regulation here is the WRDOR, or the Water Resource Development and Operating Regulations. In it, it says no well may be drilled unless the owner of the land obtains the drilling permit. If the landowner, it further states that if the landowner and the well owner are not the same, a statement from the owner granting permission must be submitted along with the application. The regs that I read said a notarized statement must accompany the permit application, but for our purposes of government to government, an email should suffice. Next slide. This is just an example from the WRDOR. This states it here. Next slide. This is a sample from an actual well drilling permit application. At the top, we have the owner of the well, stated as Blaz, but per the FAR, the owner during construction should actually be the contractor. The landowner here is, I believe is correct. And here's the fine print in the application itself, saying that if the landowner is different from the well owner, then the written permission is required to submit the application. And here's where the landowner would sign, or the applicant would sign. Next slide.
I just want to make a fine point. So the general is not going to sign these. Ms. Barbara Torres, who is the environmental director at Anderson Air Force Base, she has bi-direction authority to sign on these particular permits. So I sign for stuff that's on Camp Blaz. Barbara has authority to sign for things at Anderson Air Force Base. So you don't have to run these up to the That's not a good use of this.
Okay, and this is just for the licensing folks. This is just a sample from the contract specs. It's a blanket statement saying that you must comply with federal, state, and local laws. That's usually in a regulation, in the contract specs, or in the permit itself. Some people are not aware that of these, these requirements, but you apply for the permit, and this is a term of the permit. So it's pretty general, but it really puts you on the line for being responsible and going your information that you're applying.
This is under Division 1 spec, right? Temporary environmental controls.
Any questions?
All right, this is a quick intro. Captain Bearden is here today. He's the chief engineer for Guam, EPA. My thanks to him for providing his valuable time and sharing his knowledge and updates that pertain to military construction activities. So again, thank you, Captain Bearden, for joining us today. And the floor is yours. Thank you.
Thanks, Al. Good afternoon, everybody. I understand that everyone wants to get out of here early and on time, so we will. I'll make sure that I don't repeat too much of what we did last year, and we'll focus on some of the newer stuff. But before I do, I got two presentations, and I want to get some gauge the interest in the room on what they are. So the first presentation is more or less what I covered last year, which is what does Guam EPA review, how does the permitting system work? we've already done that, if you were all here last year. And then the second presentation is a sort of an introduction to the stormwater design criteria that Guam EPA administers in the manual, and especially with a focus on infiltration practices, which is what 99% of what you guys install is anyway. So which of those two would you rather see me focus on? Raise your hand if you want to hear about the permitting process more than the stormwater. Okay. Who wants to hear more about the stormwater design stuff than the permitting process? One guy? All right. All right, well, I guess we'll focus on the permitting stuff then. We can just click to the next slide. So I wanted to introduce myself. I heard there's some question, is this guy in the Coast Guard or what? So I'm a U.S. Public Health Service officer. If you've never heard of the Public Health Service, it is one of the uniformed services of the United States. There's the U.S. Public Health Service, and there's also the National Oceanographic and Atmospheric Administration Commission Corps. We're the two real small uniformed services that no one hears about. And because we're so small, we don't have budget to do our own uniform items. We can't hire a consultant to come up with our own camouflage pattern and such. So we have to go with what other services use. And normally we go with everything the Navy wears. We wear the service khaki, we wear the service dress blues. But when the Navy went to those digital blue camo uniforms a few years ago, they had embedded the Navy logo in the pattern here and there. And so we couldn't use it. So we had to go negotiate with the Coast Guard to get this uniform, but without the Coast Guard symbol on the front. So anyway, U.S. Public Health Service is under the Department of Health and Human Services. Surgeon General is our supreme commander, I guess you'd say, but it's not really, because the Surgeon General is a political appointee. It used to not be, but nowadays it is. I am detailed the United States Environmental Protection Agency. The Public Health Service has a long history with the EPA. When the EPA was formed back in the early 1970s, it was formed out of components of the Public Health Service. The Public Health Service at that time was a very large agency. It had uniform components and a lot of civilian workers as well. But something like 10% of the original EPA staff were uniformed Public Health Service officers. I'm further detailed down to Guam EPA. Go on. Next slide. Standard disclaimer. Next slide. So I'll just start jumping into this stuff, and at any time you guys interrupt me, ask questions. I've done this a million times already. I have updated this slightly, but what I'm going to focus on here right now is what it is that Guam EPA looks at when we do these reviews, and I'm just going to start stepping through it. So the very first one that I've listed up there is the Guam Soil Erosion and Sediment Control Regulations. This forms our kind of wraparound regulation for how we permit military construction. The word permit is a little bit, I'm not sure it really fits or not. What we're doing is we're really reviewing to satisfy the federal requirement that military projects go under environmental review and that you cooperate with the state. So we call it a permit, but it's more of a design review. We issue an approval letter that has conditions, so it's effectively a permit. The specific components that are underneath that regulation that we're looking at is the erosion and sediment control plan, and that's one of the most important sets of plans, and a lot of times we don't even get that from the contractor. Without that plan, the clock doesn't even start ticking in the regulations. If you look at the regulations, it gives us 30 days to review the erosion and sediment control plan. It's not, the application is not the other documents, it's the erosion and sediment control plan. So when a contractor doesn't even turn that in, which we see a lot, that clock doesn't even start ticking. The next piece of that we review is what's called the Stormwater Runoff Drainage System Plan. And that is the post-construction stormwater plan. And that's where this manual that we could talk about later if we have time comes into play. The regulations talk about a best management practices manual. That's the manual that's adopted by Guam. And it's the same manual that's in use in CNMI. So if you guys are doing any work in CNMI or even in Palau, it's a different manual in Palau, but it's the same manual. I actually adopted it myself for Palau like 15 years ago. It's the same manual, but just different rainfall numbers. So that's the Guam Soil Erosion and Sediment Control Regulations. That takes up the bulk of our review usually. The next big piece of it for us is the wellhead protection regulations, and these are built into the regulations that cover well drilling and well operations, but there's a separate section called wellhead protection regulations, and if you ever want to read the worst regulations you'll ever read in your life, you can take a look at those. A lot of it doesn't make any sense at all, whoever wrote them. wasn't using grammar, they weren't even finishing sentences, so some of those sections you can't even technically enforce because I think there's one section that says something like, no toxic or hazardous chemicals, blah, 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 period. Can't be used, can't be stored. It doesn't even say what you're supposed to do. But there are some pieces of it that do make sense, and we do regulate those pieces. And those really mostly apply within 1,000-foot radius of any groundwater well, or production well, not just groundwater. It has to be a drinking water production well. And as you guys know, there's a lot of those scattered around Camp Blaz, Andy South, a few up here at Anderson, but not so many that are in the way of things typically. And our review for this really is looking kind of a more big picture review and just seeing what types of activities are happening on the site, what types of chemicals are in use, what types of storage areas for chemicals. You're looking at fuel tanks, we're looking at things like vehicle wash stations, that kind of thing. And then we do our review based on that. And a lot of that kind of goes back and forth with the stormwater control regulations there as well, because whatever's happening has to be treated if it's within these wellhead protection areas. And that's the treatment requirements are inside that manual. We also look for injection wells, and we'll talk a little bit more about that later. Guam is a little bit different than other places I've worked where they have very strict injection well regulations. And so if you have a shallow stormwater injection well in a project, it requires a permit and it requires testing and sampling of that well and the runoff that comes into it for the rest of the life of the facility. And it's very expensive. I think Al can tell you guys just how expensive that is. So we try to discourage those unless you really need them. As you know, you also have what I call the real injection wells, right? The real deep ones that you have scattered around Anderson, especially that handle drainage for large aprons and runway areas and such. But what we're normally talking about here are these little shallow injection wells. And what we typically see on a project where these slide through in this review is they'll be just like a 6-foot diameter perforated concrete pit, maybe 4 feet deep, buried outside of a building and connected to a floor drain in a mechanical room, usually for air conditioner condensate, sometimes also though for other mechanical rooms. And technically those are injection wells. Next slide. And again, stop me if you have any questions. Yes, sir.
What about ponding basins?
Ponding basins are not an injection well, but that is part of the stormwater system, right? So that's what we'll be looking at. Are you talking about like existing ponding basins?
Yeah.
And what we're doing with those? Yes, so about, what about them?
Does it fall in this category?
Well, it does. So that's if you go back to the previous slide, it falls under the stormwater runoff drainage system plan and also the wellhead protection regulations. So if there's a ponding basin, it has to be located as far as possible on the parcel away from the well. If you're building a new ponding basin, it has to meet the standards in the stormwater manual, which are different than the old. It's not like the old Army Corps of Engineer manual that Guam used to use, where you just dig a hole in the ground, you dump all your water in there. There's some pre-treatment requirements that now apply. That makes it a little bit different. And if there's existing ponding basins, and you want to have your project dump into those, you have to prove that that ponding basin has the capacity to handle whatever new project you're doing. Camp Blaz has some very large ponding basins that were designed for the whole facility, so that one's already taken care of. But on Anderson, sometimes it's hard to figure that out, whether or not you've got data that can show that an existing ponding basin can handle, or if you have to come up with new data. Does that answer your question? Okay, next slide. We also look at the safe drinking water regulations. Under federal law, any change to a drinking water distribution system or treatment system requires review by the primacy agency. Guam EPA is the primacy agency prior to making that change. And they talk about a significant change, and that's been defined in the contractual language that you guys all have. I think it's like anything greater than 200 linear feet of a new pipe. Anything that would be a change in treatment. If you're working on a well design and you're going to be putting in chlorination system, that has to be reviewed. The well has to be reviewed, water tanks. Wastewater disposal. This is under the Clean Water Act, so we do some review under that as well. Most, if not all, facilities up here are going to be connected to sewer. So what we're going to be looking for in those cases is that, number one, that it's connected to sewer. Number two, that if anything unusual is happening inside of that building, any kind of potential pollutant-causing activity, like a maintenance facility or some sort of a vehicle washing facility, that those are connected through some sort of pre-treatment system that goes into that sewer to provide that treatment ahead of that. That's typically something like a well water separator or a sedimentation basin of some sort ahead of the sewer. And you also have to coordinate that with the GWA if you're discharging the GWA system. Septic tanks, outside the groundwater protection zone, and I don't think I have a map of the groundwater protection zone to show you, but it cuts right across the main field here at Anderson. So where we are right now is maybe within the groundwater protection zone. I know the base exchange is inside the GPZ, but North Ramp is outside the GPZ. Within the GPZ, there's no septic tanks allowed for anything other than residential use, single-family residence. Outside the GPZ, you can have septic systems for any number of things. It just has to go through design. And I know we have a few projects up on North Ramp that are doing septic systems that we're looking at right now. Holding tanks, this is from last year. We said it's not allowable under current Guam law. It still is not allowable under current Guam law, but we're working out an MOU with Al and his crew to allow holding tanks for DOD use under a different provision of Guam law that was never adopted. It's called the International Private Sewage Disposal Agreement. But holding tanks are something, if you don't know what that is, that's where instead of a sewer connection or a septic system, you've just got a tank. It fills up with sewage, you've got an alarm on there based on levels, and you have to come pump it out with a truck. Fairly limited usage. You can't obviously have that for a really large facility because there's no way you can keep up with the pumping. But for something like a small office or something like that, or something that only gets used during a special event, it's something that's viable. I know we have some up at the rifle range, right? And then temporary toilet facilities, that's just intended for construction only, but we have regulations about those. Next. Questions on that stuff, wastewater. Our hazardous waste program also reviews plans. These are a separate group of people from the folks that I supervise. They're mostly looking at things like fuel storage, any kind of chemical storage, underground storage tanks, USTs, that's a special permitting process for those. Above ground storage permitting, or above ground storage tanks also has a different, I think they call it a registration process, not a permit. You have to register those tanks. If you have those types of systems, they're also looking at the pipelines and the fuel piping and such that are associated with those tanks, because there are some requirements depending on how large that facility is. And any other types of hazardous waste issues. Our air pollution control program also reviews for dust control plans for during construction. It's just a basic form that the contractor fills out. It's nothing special. And any kind of standby generators or any other types of air emissions. There's a separate permitting process for all that your contractors have to go through. Standby generators is all about the location on the property and the height of the stack. Next. Our solid waste guys also look for what they call the solid waste management plan and the disposal plan. This is your contractor. This holds up a lot of permits. And we're trying right now to get our solid waste guys to be a little bit more flexible. The thing that's been holding up these permits the most is that a contractor will come in and they'll say, I'm going to dispose of my hard fill waste at hard fill XYZ over on Back Road, right? But then we find out that they're using hard fill ABC somewhere else on the island, and then it just holds the whole process up. So we're trying to get Guam EPA, and I think Guam EPA is in agreement now to just say it has to be disposed of at a permitted facility, and that leaves it up to the contractor to say who they're going to use, and they can change that as time goes by. I don't know if any of you guys have been involved in any permit renewals this year with us. Permits are only good for 12 months. We've had some permit renewals now that have been held up since March or April, only because of this. When we renew a permit, all we do is just make sure that the check is written to us in the right amount, and we give them a new permit. But our solid waste guys are looking at this information. They're getting hung up on the fact that the contractor is using a different facility than they said in the original application. So it seems simple to fix. It is simple to fix, and we're getting that fixed now. The other piece of that is that on the site design, for any new designs, our solid waste guys just want to see that there's a location set aside for the waste bins, like in the photo there. Thanks. Any questions on those?
I have one.
Yes, sir.
Storage tank. What's the service storage tank that belongs to the industry? Holding tanks.
Holding tanks. there's no concern. It's just that Guam's law is so strangely specific. If you look at Guam's law called the Toilet Facilities Disposal Act or something like that, it's Toilet Facilities and Sewage Disposal Act. It allows 3 types of toilet facilities, they're called. So for any building to be connected to in Guam, one is connection to a public sewer. The other one is connection to a septic tank and a leaching field. It actually uses that language. It's so specific. And then the third is a privy, a pit toilet. And that's not really allowed for anything other than a farm. So it's so specific that it doesn't allow something like a holding tank. It doesn't allow a more advanced on-site treatment system. We've been working, since I've been here, I've been trying to get the legislature to change that law. And I think they might be headed that way right now, but they're not there yet. But there is this other law, it's the Guam's building law. Back in 2010, the legislature adopted what's called the International Private Disposal System Code, and it's a private sewage disposal system code. And it's basically a completely different set of septic system, on-site disposal regulations, and it allows holding tanks, it allows mound systems, it allows all kinds of advanced treatment systems. So what we've decided to do is that law cannot be used right now because the way they wrote the law says that if it conflicts with any other Guam law, the existing Guam law takes precedence, so that kind of takes it out of play. But what we can do for the federal side, because the federal government is not obligated to follow every single detail of the local law. So we've been able to say basically that we are meeting our due diligence by following this other piece of Guam law that allows holding tanks. So that's something we're working on this MOU right now, and it may be solved sometime in the next few months. There's a bill in the legislation now by Senator Chris Blankus that will do a bunch of things. It picks up about 90% of what we were asking for at Guam EPA, throw a few extra things in there, but it'll solve that as well. So there's no problem with holding tanks, it's just that they're not in the law right now. This whole thing runs by law, as you guys know. Yes, sir.
Hey, you brought up the solid waste. Any advice on how to stick those stuff?
So yeah, so we're doing that internally right now. We've been talking with our solid waste guys and got them to agree that it's not going to be something they're going to hold up that much anymore. I think one of the reasons it got held up to some extent was that after the typhoon, they got just slammed trying to deal with all the typhoon waste there. So our solid waste guys were physically out in the field for 2 months straight running these debris sites. So that kind of took their attention away. But now that we've gotten them back, we've got them to agree that they're going to change the way they handle this. So the way we're going to stick it, like I said, is to no longer tie the permit to a specific facility, but just have on there the blanket terminology, a Guam EPA permitted facility. So that should speed it up quite a bit. I think there'll still be some requests to have the contractor show them where they're disposing and give them their receipts, that kind of thing. But at least there won't be this back and forth like, oh, you need to revise your plan, your plan was wrong. It seems like silly stuff, but that's what was happening. Any other questions on solid waste? Let's move on. Did we miss that last slide? Oh yeah, so back to what this permit, right? It's not really a permit, it's an approval letter. That may change though before I leave. We're trying to amend Guam EPA's regulations to adjust that to where we can issue a permit. We're allowed to issue a permit underneath the law, but not under the regulations. But regardless, we issue 3 different types of letters when any kind of a permit application comes into us. One, of course, is a hold letter. If there's any problem during the review, we'll issue a letter to a contractor, tell them what they need to give us, the revisions they need to make to the plans before we can continue processing. But then the other 2 permit types that we have here, which gets confusing sometimes, is we have what we call the full permit and the conditional permit. This is something that we just really started to help out DOT. We had a lot of projects that had very large plans, and there were a lot of issues with the plans, and we didn't want to hold up construction, so we allowed the contractor to start grading and doing their earth moving only under a conditional permit, with the condition that they don't start any construction or any final concrete asphalt pavement until they come in and get their final design approval from us. And that would be what the full permit is. The problem that we've had with that is that a lot of contractors get that temporary permit, that conditional permit, and they never look back. They never come back. They never get their final approval. then we find out that they built this whole thing, which we've never even reviewed. This is the situation behind the J755 project at Andy South. That permit was issued only for the fence. That was it. The contractor came and said, just, we're in a hurry. I had this big guy in my office, just pounding on the table. You gotta let us start. You gotta let us start. We just want to do the fence. So we gave them a permit for the fence only. A year and a half later, we're still working on design review, and we go out and look at the site, and the thing's almost finished, right? And there's a lot of stuff in there that we had actually had objections to, right? There was some regulatory problems with that. So that's the extreme case, but we see it happen a lot on smaller projects too. I think the contractors are starting to get a better idea of how this works now. Our letters now more clearly spell out if they're full or partial, and all the contractors, and I think it's due to you guys working, all the contractors now are coming into us to get their renewals several months in advance every year, so we're not seeing that kind of 2-year delay where we don't know what's happening. We're at least checking in on them once a year. And I think that's all due to you guys being on the ball now. They are 12-month permits, so if you're doing projects, make sure your contractor, at least 4 months ahead of that, is coming in to get their renewals set up. If they do submit a renewal like these guys I mentioned that are waiting for renewals in March, as long as they turn in the application on time, no one's going to go after them, no one's going to try to stop the project if there's something that's being held up by us not being able to review it. Next. Yes, sir.
I've got a question on MEC clearing.
What's that?
On MEC clearance?
Oh, MEC.
Yeah, MEC means munitions and
Yes.
I'm concerned. If you go back to your slide, I guess the question is that covered under the conditional permit clearing and grading?
Yes, yeah, if they get a conditional permit there, we only get that out if they have a good erosion control plan. So once you got that erosion control plan and your best management practices are in place, you can dig up whatever you want. We don't care, right? That's between you guys and the contractor at that point. As long as those erosion control BMPs are in place, they can do MEC, they can dig a hole to China, they can do whatever they want, as long as they come back in to get that full approval before they start building the buildings.
Sir?
Yes, sir.
Regarding the whole issue by the contractor, if the contractors receive a full letter from the PBA, they have the LOI and they get the simple letter after 10 months, and they can still continue the building at the ground, or
I'm not sure I'm following you. Can you,
we have a project that the contractor received a whole permit, the whole letter from EPA, and then they have the LOI that 10 months before that EPA received the whole letter, and they have something that we need additional information and documentation that we need to submit to the EPA. And that's still, the contractor can still continue, or they will hold everything on the clearing.
if they don't have a permit from us, a conditional permit, they're not supposed to be doing anything, right? Because that's the final thing, right? We issue a permit when we either get everything that we've asked for from them, we've settled all those design problems, or we've given them permission to at least do the partial construction. Now, a lot of these guys, when we see them struggling, we will offer them this partial construction permit, this conditional permit. But even with them, like P3000, who's on P3000 here? P3000. So those guys still, to this day, have not given us an erosion and sediment control plan that addresses the comments that I gave them like 10 months ago. So at some point, my sympathy dries up completely, and with those guys, it's gone. I have zero sympathy for them because we've offered that to them. They can just get the erosion and sediment control plan. It's the simplest thing in the world. It's silt fence and it's a sediment basin. That's it. We even tell you what the calculation is: 5,500 square feet or cubic feet per acre, right? So if they started construction already, they're technically in violation. We had the meeting with them in my office. Well, you guys are in violation. So that's the deal with the P3000. But yes, to answer your question, if they give us some things, if they at least give us the erosion control plan, they can get started. But if they don't resolve all the other technical issues, we can't give them permission. And honestly, at the prices that these guys are charging, the amount of money they're getting paid, and federal taxpayer money, and the contract conditions that require them to do this work, I don't see why they can't give us this information. You know, there's sometimes that we're slow reviewing, that's for sure. But in this case, we've gone back and forth with the same contract, I don't know how many times. But that's okay, I'm not holding it against any of you guys.
Exactly what I want to talk about.
Okay, never done. Yeah, I mean, I think that a lot of these guys, I think they've expanded very quickly. I think that they are short on people. I think these guys especially, I think they've got, just like a lot of contractors do, they've hired some environmental specialists that are supposed to be doing this work for them, who've never done this stuff before at all. They don't know what they're doing. It's just a staffing and a skills issue, I think. Thanks. Any other questions on those topics? We'll be getting into some of this a little bit more as we move on, as we start talking about the Guam EPA challenges. So now that we've talked about those, we can talk about now why there are so many delays, and hopefully we can talk about what we're doing to try to improve the delays moving forward. As I mentioned last year, Guam EPA is understaffed. Many people are doing multiple jobs. You know, I'm like everyone else at Guam EPA. I've been for 5 years now. I've been running the Safe Drinking Water program also, in addition to doing this stuff. You just can't keep up. It's almost impossible. Guam EPA is never going to hire any engineers. If you guys have engineering positions open and NAVFAC has engineering positions open, that's where the engineers are going. They're not going to Guam EPA. I think it's $42,000 now for the starting salary. It's just no engineers can come work for Guam EPA. We're not funded to do this work. We're funded to do other things. EPA gives us grant money, but it says, you know, we have work plans to go with that grant money. That we're supposed to be doing things like helping GWA come up with their list of projects for new sewer lines and stuff. A lot of other issues. I won't go into the rest of those. We move on. This is just an estimate I put together last year about our staffing. So this column up here shows how many people are supposed to be in the water division program at Guam EPA. You know, I think it's supposed to be up to 14 engineers. This is how many we had in 2021. This is how many we had last year. It's the same this year. So we're down to about 6 engineers total. Those engineers, like I said, are also doing things like drinking water programs. They're permitting all the wells. They're doing all this other stuff. I'm trying to corral them to do design reviews at the same time. But they're all within 2 to 4 years of retirement, every single one of them. And that was 2 years ago, so they were all within 1 to 3 years of retirement right now. And I'm moving on myself, as I may have mentioned to you guys. I'm moving on to my next assignment in just a couple months. So it's not getting any better at Guam EPA. In fact, it's getting worse as we move along in terms of staffing. Next. Our current load has been getting steadily higher. I've been keeping these records since the middle of 2019, and you can see the dashed line is Excel's attempt at showing a trend. So we've gone, you know, we see a steady increase in permit load. Next. And then here's the big one that's been really difficult for us. These are military permit actions. This is the total number of permits we do per month, and then over there it is as a percent of all the other design reviews and such that we do. Last year, about this time last year, we saw a sudden jump in work, and it stayed up pretty high. So the military permit load has gone up enormously. And even though this is a small percentage of what we do on a daily basis, a military permit is worth about 30 or 40 civilian permits, just in terms of the amount of paper that you have to, the amount of drawing sheets you have to look through, the amount of the VOD you have to read and all that. So this has been a big change for the Guam EPA staff to try to keep up with this, and it's not going to get any better. I think I'm surprised that it kind of tipped down there this year. I know that you guys have a whole bunch of things in the pipeline that are coming soon. I know we have a bunch of stuff in our queue plans, and it's mostly because of our experience finding all these injection wells scattered all over these facilities, and also trying to make sure that we're doing our wastewater pretreatment review. If we don't know what's happening in a building, if we don't know that there's a maintenance room or something like that, or some sort of a repair shop, and we're not doing our job. So how to prevent delays, again, give us all the documents, just give it to us all. It's a lot, I understand. We don't need to see all the specifications, but we need to see all the drawings, basis of design. There's some things we don't look at necessarily, though. We don't need to see the communication design. We don't need to see that stuff. We don't need to see anything that we're not authorized to see. but just don't assume that we don't need to see it. A lot of times the contractor will come in not only just with the civil plans only, but they'll only take out maybe 10 sheets from the civil plans and give us that. Like, well, we thought this is all you need to see, but no, you need to see a lot more than that. Next. Again, this the plans that we want to see, the full site civil plans and basis of design, just all the civil plans. The architectural plans, the plumbing plans, and mechanical plans. And you see there, I note there, the floor drain connected to a dry well is an injection well. One thing that we're still seeing a lot, and I think we saw this especially on P3000, right, is the erosion and sediment control plan. That's supposed to be an engineered drawing. That's not supposed to just be the previous engineer's site plan with the contractor working inside Adobe PDF and drawing red squares on top of things and typing things on them. And that's what we're seeing, right? We've still got the engineer stamp on there who had drawn the original plan, but that engineer had nothing at all to do with that erosion control plan. Guam EPA's regulations require that, and it's just professional practice. No contractor should be turning in any kind of a design that's not stamped by an engineer. Should the contractor lay down stockpiling areas reserved in that plan? Again, that's a lot better now. Talk about sediment basin sizing. Last year, we implemented the erosion and sediment control training certification requirements. The contractors have all done a great job. They're all coming into us now with their site certificates. And I'm kind of curious if you guys have seen an improvement in compliance on site now that these guys supposedly have the training. Have you noticed any better installation of silt fence, any better maintenance of sediment basins? It's better? Yeah, I would hope so, because that's a good class, and you attend that class. Everyone I've talked to that's attended the class like, oh, now I understand this, I'm going to do a good job at this. I hope so. Next. Solid waste pointers, again from last year. Make sure that those things are all turned into the application. Make sure that they match the facility they say you're going to dispose it to. Make sure that's the same one. I'm hoping that this gets easier to deal with, though. Stormwater design pointers. It's an in-depth engineering thing. I made this long presentation you guys don't even want to see, but we could go into that. But we do have the design review checklist there. Our manuals are all available on our website. At the very least, we can put these slides together and put them on our website as well. And some of the best application I've seen, which I don't know if I've got a picture of it. Can you go to the next slide? No, we don't have it. But some of these contractors are getting, the engineering contractors are getting really good with these basis of designs they're turning into us. You know, they're showing the site, they're showing color-coded all the different drainage areas, they're showing us on that same plan exactly what the water quality volume is and how it's met and what volume is provided on. So it's about a 5-minute review when they do that kind of thing for me, as opposed to sometimes a 2 or 3, 5-hour review if I have to dig through and find all that. Okay. All our manuals are all on our website, Guam EPA, or on the regulations or the compiler of laws website. I think our website was down last week, though. I'm not sure if it's back up. Thanks. Again, full versus partial construction permits. We went through that in some detail. Question before I rush through all this? All right, next. Renewal permits. So we're trying to make this a lot easier now, like I mentioned. It's just ridiculous that we have renewal permits sitting in the queue for months and months at a time. We're trying to get that to the point where all they have to do is submit a new application. It's a one-page application, very simple. Pay the fee, and we just give them a one-page renewal letter, basically. That's what we're trying to get it down to. And we've got that about 99% of the way there. It's just getting the solid waste guys to agree to this, which I think they have. For a partial permit, though, if someone gets a conditional permit just to do earth moving only, we don't issue renewals of that because we expect them within 12 months to come in and get that full design approval completed. Thanks. All right, any questions on that at all? Otherwise, I'm going to jump into this stormwater design presentation, which it didn't sound like very many of you were interested in. Want to take a quick break, or you guys got any questions?
All right,
And then I'll do some of the stormwater design stuff just so you guys can see. You got some good designers out there, and some that they could be doing more interesting designs or designs that will serve you guys longer term. see stuff that will probably clog up very quickly. We can talk about that.
10-minute break. Guam EPA for, I don't know, at least 4 or 5 years, establishing a memorandum of agreement for cooperation to help streamline and expedite some of our construction permitting processes, and particularly with design reviews. We've made some advancements in resources. We got Indo-PACOM funds to hire 2 project engineers to actually do quality assurance and quality control of some of our permits and design reviews that are going into Guam EPA. We've identified 1 candidate that is now going through the hiring process. We're looking for another PE to help you know, with the staff that supplements some of what we're trying to do in terms of improvements at Guam EPA. But on top of that, we've also been trying to prioritize those projects that are, you know, high in the national security ladder in terms of being able to complete their work. So each individual ROIC or FIAT has the ability to change the prioritization of, you know, the overall list. However, they have to go through NAVFAC MAR Ops. So Commander Eichelman is the arbitrator of which projects go above which, and he'll typically ask the ROICs to basically say, what is your #1 priority? And then maybe rack and stack your projects, communicate that to Claire Barati, who's actually a Camp Blaz environmental person working with Guam EPA on this priority list. And then, you know, I review it just to make sure that, you know, the placement and priority is accurate based on direction that we receive from J4 and J4 staff. So that's one of the few ways that we can, you know, basically if we got something that's really, you know, hot and it's at the headquarters level, people are very concerned, please push the button on the change in prioritization. We'll help you out with that process. But that is a process that goes through NAVFAC MAR Ops Commander. Do you have anything to add to that?
No, other than, you're not on the microphone, I am. I used to not be, I want to shower. I think the biggest thing that can help Guam EPA right now is getting those PEs that Al mentioned. So we got 1, which is great, and hopefully we'll get that person started soon. We can train them, get them up and going. You called it quality assurance. Basically they're going to be doing the design review and the permit review for Guam EPA, and then providing that checklist we talked about as their final product. And then they have to build up some trust with the Guam EPA folks to see that they trust that they did a good review. But that should speed things up a lot. I think with 2 PEs on board, we can keep up with all our work that's coming. I really do think that it's just, if I could do it all myself, 24 hours a day, or even just 8 hours a day, I could have kept up with this as well. So that's going to be a big benefit. We've also got somebody starting soon that's just like Claire, right? She's going to be like an admin person that helps us organize this and helps us keep track of this. And I guess keeps track of this priority list.
So help is coming. Unfortunately, it took some time and also took some convincing at the very high levels that this is something worthwhile. But as you can see from the statistics that you know, that were presented here, this is something that will really help. You know, if the overall trajectory of Guam EPA staffing remains the same, this is going to be critical to getting some of our stuff done. So, but yeah, my thanks to Guam EPA, Captain Bearden particularly, and leadership at Guam EPA for, you know, entering into an MOA with us on this particular topic and, you know, seeing the results of all of our hard work. So thank you.
Yeah, and we'll be trying to replace me with potentially another public health service officer, if we can get one. As you guys know probably, the engineers are short everywhere, even in the public health service, so it might be tough to get somebody willing to come out here.
Any questions?
Unfortunately, you can't just force people to come here like you guys can.
Any questions on the collaborative agreement with Guam EPA and points of contact for either prioritization or trying to get your projects, you know, unstuck, you know, in the process? Wait.
The checklist you were referring to, is that available?
Yes, it's online. It's on the Camp Blaz website. Look up Camp Blaz Environmental Program. Just Google it. We'll also distribute the links after the training to all the resources that have been presented.
Should we talk about the upcoming potential changes to the timelines? Or that's still
that's still
sorry.
yeah.
All right. And we'll talk about that. Okay, so I'm gonna just kind of get into this, but I will cut it off a little early maybe before we get into too many details. What's our deadline here now? 2:30?
I would say earlier the better,
Okay.
2:30 or somewhere thereabouts.
We'll stop before we get into many of the details. I'll just give you kind of an overview of the stormwater design and maybe try to explain some of the things that I think would be beneficial for you all to know as you're designing these things. I think there's been some nice choices that have been made. It's just from the designer, but not very practical choices for some of your projects. Go ahead. Same stuff, same intro. Okay, so overview on this presentation, which I won't go through the whole thing, it's just an overview of that CNMI Guam stormwater manual with a focus on infiltration because that's what we do in northern Guam. Talk about some of the general requirements, some of the simplified criteria calculations that we developed, and some hints, tips, and observations from Bill Kahn. And I had some stuff about UICs and hotspots later we can talk about. So next. So the way these manuals are structured, I'm just going to kind of talk about the general structure. Volume 1 is really just 3 chapters, but they're very big. Chapter 1, introduction to material. Chapter 2 has all the criteria and standards that have to be met, including the way that they are supposed to be calculated. And then chapter 3 is a listing of all the acceptable stormwater BMPs, including a final section on what they call limited applicability BMPs, things like boil water separators and things that can be combined with these to meet different criteria. Next. The volume 2 of the manual has a whole bunch of design tools. It's got selection matrices for how you select BMPs for a site. It's got a chapter on better site design, which is essentially the same thing that you guys have with your LID, low impact development standards. You guys have LID standards, right? It's got a bunch of design examples, and we run into a lot of engineers that do these big projects that aren't aware of this. They're like, well, how do I design this thing? Well, there's a whole design example that steps you through every point, every step of the way. It's got landscaping guidance, some specifications, maintenance plans, a chapter on soils, and then a bunch of stuff for the engineers that are rusty on some of those materials. It's got equations and how you do some of the calculations in the back. Next. So getting into the actual criteria, what we're looking for on these designs, if you go into the chapter 2 of the volume 1, which is this criteria, it's set up in a couple different sections. One is erosion and sediment control requirements, and then the second one is the post-construction stormwater management plans. And under the erosion and sediment control plans, there's 11 general performance standards, and under post-construction, there's 13, plus the unified sizing criteria, which I'll talk about in a minute. Next. On the erosion control side of things, there's a whole bunch of things in there, but the ones I wanted to highlight for you today were that, and this is one where I don't see much traction, is the standard, and this comes straight out of the federal guidelines for your NPDES construction general permit. As soon as a contractor finishes work in any area, any earthwork, within 14 days they're supposed to stabilize that soil. That can mean putting down mulch, that's kind of an instant stabilization. It could mean putting down tarps covering something. It could mean establishing an initial growth of grass with seeding. But we don't see people doing that much. I saw huge portions of Camp Blaz remain just bare dirt for years at a time and wash into those nice ponding basins and clog them up. Sediment traps and basins, I won't spend any time on that. We already talked about that. The sizing is very easy, but we do require those where a silt fence is not enough. And speaking of silt fence, how do you know that that's not enough, right? The typical guidelines for a real gentle slope, like a 2% or 5% max slope, there's no more than 100 feet contributing to that silt fence. So if your site's bigger than 100 feet, we need sediment traps. Certification of erosion sediment control training. We talked about that. The contractors have to give us that now. That's for the site superintendent. It's not just supposed to be for their environmental specialist that's on the site. It's supposed to be the guy that's managing that construction site. He's supposed to be the guy that knows what he's doing with erosion control so that he can direct his staff to do the right thing. Because we all know how these construction sites are. The EV person usually doesn't have much clout. Next. Oh. Sorry, last one. I skipped over the one of the best management practices have to be aggressively maintained, right? So sometimes we don't see that. Sometimes we see silt fence being knocked down or sitting there. Some other pieces of that, you can go back. Oh, that was it. Next slide. I'm sorry, I didn't know you went back. Post-construction, I'll just hit a few highlights here as well. There is a impervious area maximum in the regulations or the standards for 70% max of site is supposed to be impervious. I think all of Camp Blaz is designed to that standard. I think most of your projects on Anderson are also designed to that standard. But there's some exceptions to that. Mostly apply in urban areas, maybe not necessarily on a military base. Our BMPs are supposed to be removing 80% of total suspended solids, but that's not what we're looking at. We're looking at a design. Basically, if it follows all the criteria in the manual and is built properly and maintained properly, it's assumed that it meets that standard. We can also require additional requirements for sensitive resources, which explicitly calls out wellhead protection areas. And then hotspots have specific design requirements. I wanted to show you this picture up here. I don't have a lot of time to get into the details later. But I hear a lot of times from the designers and sometimes the construction managers on a project where we say that's a hotspot, it needs hotspot treatment. Like, well, we can't fit that in the site. This is a hotspot treatment system. This is an under pavement sand filter. You can fit it in your parking lot, you can fit it in a driveway. We've got these at a number of gas stations around Guam right now. These are great little systems. They serve as a a very simple oil water separator, basically like a spill containment unit, and a very easily maintainable sand filter inside it. That's just grading you can remove, and the guys can get in there and rake the oil or whatever else is accumulated on that sand surface. And you get excellent treatment with those things. So you don't have to have another acre of land to do a hotspot treatment. These things can fit in a very tight area. They can fit along the edge of a dock, a wharf. Thanks. So in the manual, there's these 4 sizing criteria, and we see a lot of engineers get all worked up about these. We have the water quality volume, we have a recharge volume, we have this thing called the channel protection volume, that's a 1-year storm, and we have this thing called the extended detention of overbank flood control volume, the QP25. When you're in northern Guam and you're just going to be infiltrating all of your stormwater, there's only 2 you have to worry about, and that's that last one, the QP25, that's the 25-year storm. Because once you've got that 25-year storm, you've covered all the other storm sizes. And then the other one is the water quality volume, because you do have to provide treatment ahead of that final ponding basement. That's the difference between the new manual and the old Army Corps of Engineers manual, which again was just a hole in the ground. You get rid of all your water in that hole in the ground. The difference here is that we are providing at least some treatment. In many cases, the treatment is mostly just to prevent that ponding basin from clogging, just by removing sediment. But in some cases on hotspots, you're also doing water quality, real water quality treatment. Thanks. That's the water quality volume. We won't go into that. I didn't know, I thought I was doing like an engineer training session here today, so we'll skip that. Same thing with the QP25. I did want to talk about this a little bit because we get a lot of complaints from engineers, and we even get complaints from like the University of Guam professors, mostly the GIS professors because they're not engineers, right? Like, why are you using this number, this 20-inch storm? That's not the number. Here's the correct number. It's the NOAA Atlas 14. It's 13.1 inches. That's the 25-year, 24-hour storm. And so that number, our 20 inches we're using did not just come out of thin air. When this manual was put together 20 years ago now, we worked with the University of Guam, Mark Lander. You can go to the next slide. And he put together a rainfall analysis for us. And he went back and looked at all the actual data in Guam. And basically found out that the way the Army Corps of Engineers does it, the way NOAA does it, the way the NRCS, USDA does it, they're completely missing these typhoons that we get in the Pacific that are really our 10-year plus storms, right? This dashed line here basically is the calculations that NOAA, NRCS, Army Corps of Engineers use to calculate their return frequencies for storms. The black dots are actual data from Guam, right? So you can see as you go out along the bottom here, these are your larger storms coming off this side, and your return periods up here. You can see that your longer return period storms have these really high rainfall amounts. And the way this calculation works is they use to come up with these numbers from the NOAA chart. It just basically it's a logarithmic scale, right? But it draws a straight line of a logarithm, and you end up with these numbers that fall up there on those green stars, and they're completely inaccurate. So if you're really trying to protect a site, especially a critical site, like a runway or a military installation from storms, you don't want to be using those NOAA numbers. You want to be using numbers that are based on actual Pacific Island conditions, and that's where those numbers come from out there. So Mark Lander, you go to the next slide. Mark Lander came up with this 20-inch storm based on his charting of that, and especially looking at specific storms that had hit Guam and CNMI. Just this year, we've got, I was following the National Weather Service TGen site, and they came up with some more recent data that updates, because this manual was put together in like 2003. There's 2 storms that have happened since 2003 that have hit that 20-inch mark on Guam. One was Typhoon Tintin in 2004, and one was Mawar in this year. It was over 20 inches we got out of that storm. So this is not just some extreme number that a professor at EOG came up with. These are the actual numbers that we see. And so when you're designing a site on northern Guam, and you guys all know northern Guam, there's no rivers, there's no streams. Whatever floods on your site is going to go to that low spot, and it might be your neighbor's house, or it might be a critical military facility, and it's going to stay there. So you have to know what you're designing for to make sure you don't flood it. So that's why I want to spend some time on that. Again, I think that number probably really mostly matters for sizing that basin. If you're doing things like sizing a pipe, you can probably use the NOAA numbers. That's a different type of issue. Next. The manual really focuses on, I don't want to, if I see people falling asleep, I'll stop. But the way the manual is written, we had a contractor that came from the east coast of the U.S., and he wrote this manual based on a different type of geography, right? He wrote it based on places that discharge into rivers, like the Potomac River. I think this guy came from Maryland. And so there's a method in there that shows you how you design a basin. And a lot of the engineers on Guam are using that method. And it's totally wrong. It's based on this scenario where you were trying to match pre-development flow out of a pipe into a river. In northern Guam, as I mentioned, that's not how things work, right? If you had a site before you developed it, like look at this golf course, right? There's really no clear discharge point. If you had a big storm, where is the water going to flow off? You don't really know. It's going to probably sheet flow off everywhere you look. But after you build it, it will flow off somewhere, right? Because you're going to put in your grading system, you're going to put in pavement, and there's going to probably be a ponding basin, and that ponding basin is going to spill over in a big storm. And where is that going to go? It's probably not going to go where it used to go before the storm. It might go into somebody's backyard. So you have to think about these things differently. So what we've done is we've come up, you can go to the next slide, we've come up with a different way to do this. Hold on. Go back to that last slide. We've come up with a different way to do this in northern Guam, and this has been working with a few of the engineers here on the island, some of the professors at UOG, where it's a very, very simple method of just basically disposing of that entire volume through your ponding basin. But now you can go to the next slide. So the question now is, if you're designing these things, do you dispose of the entire volume, or do you go ahead and calculate what you used to have on the site and take that delta, the difference between pre-development and post-development? And so we come up with a basic rule, right? So if you are discharging to some sort of a drainage system that goes to a big ponding basin somewhere, like the ponding basins at Camp Blaz, you can design to the delta, because then the overflow is controlled. You're not going to flood anyone's critical facilities. If you are not, if your site's just a standalone site and you're just going to build a basin and you don't really know where it's going to go after that, you should try to design it to dispose of that entire 20-inch storm. And it's not as big as you might think. Next. And so this is the calculation we came up with. It's way simpler than the method in the manual. You just take the volume of your runoff, you subtract the volume of infiltration through that basin, and that gives you the size of your basin. It's extremely simple. We have this on spreadsheets that we can share with people. If you guys want to review the work your designers are doing, you can use their spreadsheet to check their work just like you. Next. Again, I don't want to spend too much time. You can skip this. This is a simplified method. You can put it in a spreadsheet. Very easy to put it into a spreadsheet. Next. Next. So selection of best management practices. I did want to spend a little bit of time on this because I do see things once in a while that don't make sense to me, but they're not illegal, so we just let them go ahead, and then you guys get stuck with the long-term performance. In volume 2 of the manual, there's a whole bunch of these tables that, by different types of uses, right? It tells you what type of best management practice to select. This one here is probably the most useful. It's by land use. And I like this one because it's got a column for hotspots here. You see here. Along the side there, you see your BMP types. So if you look at the hotspot use here, for example, there's a lot of hotspots on military projects, so I want to spend some time on this. Black dot means no or seldom. So you look here, this is the infiltration practices up here. Is there a pointer or do I stand here? I'll stand here. That's fine. Infiltration practices are considered to not be a good hotspot treatment because the whole idea is that all your water is going down into the groundwater, so you want to treat it. So you move down here and you look at other things that are useful for a hotspot treatment. And you start seeing these circles with the numbers. So circle with a 1 in it up there at the top for ponds and wetlands. When they say a pond here, they mean an actual wet pond. A circle with a 1 is an acceptable option, but may require a pond liner to reduce the risk of groundwater contamination. But we're not going to be building any ponds or wetlands in northern Guam. It's just not the right place. So down here, you've got the circles with the 2 in it. And what those say is those are an acceptable option if not designed as an X-filter. An X-filter is a conventional stormwater filter without an under-drain system. So basically like a sand filter, but you just let it drain out the bottom. So what you have here then is you've got all the filters, right? You have sand filters, organic filters, bioretention, and the dry swale. So these end up being your main hotspot BMPs here if you've got a hotspot site. And we'll try to get into what those look like here in a minute. Next. So the manual has a whole bunch of different practices. We'll just skim through these real quick, just so you can see that there's a lot more than just the ponding basin that we talk about, which is really an infiltration basin. Next. So stormwater ponds, there's a whole chapter in ponds, about ponds. They give excellent water quality treatment, but they require a standing pool of water, and that's tough to get in northern Guam unless you put a liner in. That's actually the Rotary Resort. That's not really a stormwater pond, but that's a golf course pond, just 40 miles north of here. Next. Shallow marsh, stormwater wetlands. Wetlands also give excellent treatment, but again, it's not something you're going to be able to design much of in northern Guam because water has to stand. That's also from the Rotary Resort, but that's their wastewater treatment wetland. They have a really cool system there when they were open. Next. Here's what we get into now, mostly in Guam, right? Infiltration practices. That's just an infiltration basin. The manual has a much more complicated design, but they can just be a hole in the ground, basically. Next. Filtration practices, I want to show you guys a little bit of these. Bioretention is shown there. Some people call these rain gardens. Biofiltration is what the manual uses because it's an engineering practice, not just a landscaping thing. Next. And then open channel practices, things like swales. But these are not just ditches, right? These are engineered swales with a soil component in the bottom. Next. Each section of the chapter, each section of the manual has a great amount of detail, and it tells you how to apply these things next. We'll go into that stuff. But we'll talk about infiltration BMPs and why it's so important to know how this stuff works, right? Since this is what everybody uses. And this all comes from our original manual developer back 20 years ago. Infiltration got a really bad reputation back in the 70s and 80s. Maybe not so much out in Guam, but in other places it did. Mostly because they would clog up and fail real rapidly. And that does happen in Guam. We'll see that occasionally. If you design them properly, though, the failures are reduced, and that's part of what this manual was designed to do, is to make sure these things are going to last a long time. It's a true post-construction practice. By what they mean by that is that if you put it in during construction, you're going to clog it up and it's going to fail. And that's where I get worried with a lot of the project sites I see around here. And the contractors always want to use the infiltration basin as the sediment basin. And we've given them some leeway, and I said, well, you can do that if your sedimentation basin can be under-excavated to the point where you can come back and dig up maybe another foot or two down below it to get rid of all that clogged soil. But I'm not sure if that really protects it or not. But some of the sites are pretty small, and so we let them get away with it. Next. Some of the things that are important with infiltration systems is that pre-treatment is required, and the pre-treatment on a hotspot is for water quality, but in most cases it's just to prevent clogging. At Guam EPA, if you look at the manual, it will tell you to go all the way up to 100% of the water quality volume for pre-treatment based on our standard infiltration rates we see here, right? But we've determined, we talked to the guy who wrote the manual, we said, hey, I don't really see what the point of this is other than removing sediment. And if you design a sedimentation basin, you come up with a much smaller volume. So we've reduced that to just 25% of the water quality volume. So if you don't have a hotspot site, you can get away with 25% water quality volume for pre-treatment. But hotspots have to provide 100%. Next. Again, has a slide, the mention of Guam's new rules that we've come up with. And the manual also has a whole list of things you can do. In addition to a settling chamber, you can pick 3 of these other methods that are in there, such as different layers of sand. You can go to the next slide, this shows it here. This is from the manual. This is an infiltration trench where the whole thing's filled with gravel. But at the bottom, it has what they're calling a sand filter or the fabric equivalent. So basically just a filter fabric at the bottom. And then the same thing up at the top there. It's got another layer of pea gravel. And the idea of those things there is just to catch sediment before it clogs up so that you can be able to get in there, dig that up, and replace it if you have a problem on site. And I've seen this in action. I've seen a couple of sites here where contractor didn't do erosion control when going out. One especially was a Subaki Hotel. You guys know where that is in Tumon? So when they were building that, right when I got here, they didn't do any erosion control. It was a disaster. They were discharging to the ocean. We fined them like $100,000 or something. But they had an underground infiltration chamber there, and it had a 12-inch layer of just real coarse gravel, like 1-inch gravel. And all that sediment that had washed into that infiltration chamber was all stuck in the top 3 or 4 inches of that gravel. So it was really amazing how much that could remove. And they were able to then, because of that, and they also had the filter fabric underneath it, they were able to then just pull that gravel out, wash it, reuse it, and get rid of that filter fabric and replace it. They didn't lose their infiltration chamber. So it's like an insurance policy, right? Next. Table in the manual, it gives you infiltration rates that you can assume. You don't have to do a measurement, but it's based on soil texture. And we're all in limestone up here. We're not in the soil. So what do you use for limestone? You use half of the measured infiltration rate. So your geotech will do the infiltration rate. You just use half of that. Next. There's some other details there. Let's skip all that. I don't want to keep you guys here forever. You're just going, that's fine. Let's just keep going. But one thing I didn't want to talk about here, leave it on this one here. There's a concept in the manual that I don't see many engineers do in practice. It's called offline treatment. So if you're doing water quality treatment, the idea is you're supposed to be doing it offline, and here's offline versus online, right? So this is an online treatment practice. And what that means is that every inch of rain that falls on that site is going to flow through that BMP. So whatever you might have accumulated in there, sediments, oils, any other kind of contaminants, it's just going to get flushed away every time it rains and go right into your infiltration basin. An offline system, on the other hand, so this has got something like a little weir blocking the channel. It will divert that first water quality volume, maybe the first 0.8 inches of rain, into your water quality practice, and then any bigger storm will flow over the top of that weir and bypass it so you don't flush out all those contaminants. And I don't see that used by many of your engineers, and we don't really hold them to it. We probably should, but we're fighting so many battles. That's one that we've just given up, I guess. But that's something I'd like to see them using more often, because it will help keep your ponding basins working longer. Next. We'll just skip this. I want to get into some of the hotspot stuff. Next. So stormwater hotspots. So this is one that comes up a lot. We get a lot of arguments from you guys as well as the engineers on what is a hotspot. Got 2 definitions out of the manual. One's in the actual section on hotspots, one's from the glossary. They're both slightly different. But what I try to tell people when I talk to them is like, yeah, just because it's not in that list of potential hotspots doesn't mean it's not a hotspot. It's a concept, right? So if your site has an activity that would generate a higher concentration of contaminants, hydrocarbons, metals, whatever, then that's a hotspot, right? Just because it doesn't fall on that very short list of potential hotspot locations. I think that's on the next page. Where's the next slide? Can you try that? Okay, here's the list that's in the manual. Just because it's not on that list doesn't mean it's not a hotspot. We had that with P609, right? Who's P609? We were just talking about that. We're talking about that. So there's a spot there where it's going to be a fuel top-off pad, right? Very small pad, which is good for a hotspot because you only have to treat that area. They're like, well, it's not a permanent fueling pad, it's just a temporary fueling pad. Well, the way I look at it, right, is that it's fueling. These guys are going to be spilling that fuel off and on, especially when they're topping things off, they're going to be overflowing. It's just going to happen, no matter how careful you are. And over time, all that petroleum is going to soak into that concrete surface. It is not an impermeable surface. I mean, supposedly, but it will absorb oils, and over time that will run off. And I think that anyone who's ever done stormwater inspections, right, NPDES inspections, you get around those types of sites, and you see that sheen in the water nearby, and the EPA inspector nails you for it, right? So those are hot spots, right? And that's what these are meant to handle like that, but that's a hot spot. But I'd like to hear any feedback you guys have. That's just my guidance on what a hot spot is. No?
You provide a safe guide.
Okay, next. Now we'll skip this, just the details of how you design hotspots. Again, there's that sand filter. Go to the next slide. Did it skip something? I was just going to say that a sand filter combined with the oil water separator is kind of a common hotspot treatment. Next. I want to get into some of the details. Go ahead. We'll show you some pictures now. That's just how well they treat stuff. Next. So these are the filtering practices. So this is the basic, we can go to the next slide. I can go back to the next slide, I'm sorry. I didn't have a chance to practice this. So this is your standard sand filter, right? You've got a sedimentation chamber and an open-topped sand filter bed at the end there. What's not shown in that diagram is something like a perforated under-drain that would then drain that water out to your storm drain system. This might be one that's unlined, right? Next. Here's a photograph of that type of system in place. It's a pretty ugly type of system, right? You guys been up to North Ramp, you've seen that huge sand filter that's built up there on the side near that that sinkhole coming off the P603 or whatever that hangar that was built there. Anyway, we see you've got a bunch of these things built around Guam. Next. Here's the basic schematic of the underground sand filter, right? So you've got this sediment chamber here, which also serves as an oil water separation chamber. You've got a bypass pipe there that will allow bigger storms to flow past it, and then you've got your sand bed at the end with a perforated underdrain that goes out to your practice and provides the treated water. Very, very effective at removing trace amounts of hydrocarbon, trace amounts of metals, gets rid of the sheen that you see on these sites. So it's a very effective system. Next. Same diagram, or same photo I showed you earlier. There's a diagram in the manual. It's an example, which I called out on the slide there. It steps you through how to design it. Really cool, really compact system. And again, I've seen several of these built on Guam now, at a mobile and a Shell station, a couple of mobile stations. Next. Organic filter, same thing, but it uses compost, or it uses peat moss as the main filtration medium. But sand's a lot easier to get, a lot easier to replace. Next. Bioretention. So this is the one that I want to talk about, because we see this, the designers love to use this. They're using this in all of your swales, they're using this in the bottom of your ponding basins everywhere. They're really cool, right? So the idea is that you catch your runoff, goes here, it filters down through this engineered soil, and then it either goes out under drain or it just percolates down in there. You get excellent treatment. Next slide, we'll go into the details. Here's some cross sections. Next. Some photographs of what they look like. I showed you this one earlier. Next. But here's the problem, right? So they are, because it's basically just soil and you're planting a bunch of stuff in it, it doesn't really infiltrate very quickly. These are really meant for small areas, right? This is a great location to do it. It's just a simple little island in a parking lot. But what's happening there is that they didn't finish construction. They built this thing, they turned it on before they finished construction, and a lot of sediment got washed into that. You go to the next slide, and it just trashed the thing, right? So these are extremely fragile practices. If any of your BMPs are using this, whether they are dry swales that they're putting it around the perimeter of Camp Blaz, or those big ponding basins at Camp Blaz that have this material specified for the bottom, I don't know if it's actually in place yet. I'm guaranteed by now those things are in this condition, and they'll have to be replaced, and that's going to cost a lot of money. Next. Just some photographs of one of these things being put in place at a median or island at a parking lot. You can see the engineered soil there. Next. The engineered soil, by the way, is like 50% sand or more. It's a very granular soil so that it allows water to filter through it. That's the same parking lot with the finished product there. Next. Similar thing, because these things will only take a certain amount of water, they're always designed with a catch basin just a couple inches higher than the rest of it. The manual tells you how to do that, and that's for the larger storms. They go down that catch basin, go out to the main one next. Next, there's some references to the design examples if anyone wants to see it. Next. Dry swales, very similar. They're basically just a swale that has this soil on the bottom. I won't spend much time on these, but you can go to the next. But they have very, very high efficiencies for treatment if you design them right. The key with these is that you have to hold the water in the swale. It's not just a ditch. That's why these are different than a ditch. You can see that one has check dams. When they talk about a check dam in the manual, it's different than a check dam that a contractor uses during construction. It's not just a pile of rocks. It's an actual impervious dam that will hold that water back to a certain level. Next. Just some photos of some of these things taken from other places. I think that's mostly what I want to talk about, but you can go on, just pass by this. Keep going. We talked about injection wells earlier. Here's a link to the EPA page. If you do question whether Guam EPA is correct, which I did when they first brought it to me, I was like, this is ridiculous. These can't all be injection wells. Unfortunately, EPA, the U.S. EPA changed their definition of what a shallow injection well is, and they have this kind of a decision matrix you can follow down there. It has these questions that ask you. If you answer yes to any of them, you have an injection well, and we mostly get to the yes with most of these designs that we see. Next. Anything that uses those underground injection chambers like you see there, those plastic infiltrator chambers, those are all injection well by Guam standards. They're not a CNLI. CNLI just does it differently. Next. And there's our friend, the concrete dry well, which this diagram is straight out of the manual. So this is a practice recommended by the manual, but in Guam, it's an injection well. What am I called? Next. I don't have an answer for this one. If anyone wanted to ask this, I know this has been a question coming up a lot, is whether oil water separators are underground storage tanks and require permits, even if you make a concrete one yourself, and it's just for stormwater treatment. To me, it should not be a UST, but that's another piece of Guam EPA that I don't have any control of. And I tried to get some input from those guys before I came here, and I couldn't get them to commit. I think you guys are having the same problem.
So basically, our guidance to the contractors is to get installation permits, but that doesn't mean that the government agrees that oil water separators are used. So we just want to get through the process of permitting and this construction curve, but we're not agreeing to anything pertaining to these systems as being UST.
Yeah, well, I certainly don't think a stormwater oil water separator is a UST, because we're talking about catching the sheen on a surface, or maybe the occasional spill. I don't have an answer to this one, but it's the same questions I raised to the Guam EPA staff, like, okay, so the grease trap outside the kitchen, is that a UST also? Same thing. All right, next. That's it. So I blazed through that. Yes, sir.
I had a question about the hot spots. Is there any gray area since it was considered a hot spot?
Any gray area? Yeah, there's always gray area. That's the problem, right?
I was wondering if the designer had known when they designed that it was a hot spot, specifically on my project.
Yeah, I mean, they should consult with us. That's the first thing to do. And in that case, they have, but they just are disagreeing with us. So that's where I'm not sure what to do. All right, well, that's all I got. Any other questions? Any other topics you wanted to ask me about while I'm here?
Just one final call for questions, concerns. Otherwise, this is it for this training, and I just want to extend my heartfelt thanks for the Camp Blaz compliance team for preparing this venue and also preparing some light refreshments for everybody here. Let's give them a round of applause. Thank you. Lieutenant Feder Barrett, do you have any parting words, or we're good to go?
Just like to thank you for your time, thank you and your staff for setting this up. I think this is something that we can all get better on, and I know that we got to drive our contractors to be better so that we can build faster. Appreciate it.
Thank you. All right, thanks everybody. All right.